Imagine you want to build a machine, right? And this machine needs to be capable of outperforming human civilization's entire computing power.
Like the computing power of the entire globe.
Exactly. Every computer on Earth combined. Now, if you go and ask Intel or Samsung how to do that, they will tell you it takes, a $20 billion foundry.
Oh, at least.
Yeah.
Plus those extreme ultraviolet lithography machines.
Right. The ones that weigh over 100 tons each.
Yeah.
And a supply chain that literally spans the entire globe.
Yeah, it's a massive, massive undertaking.
But today, we're looking at something very different. We are digging into a defiant manifesto that claims you can achieve that exact same computing supremacy this weekend.
Which is wild.
It really is. And the craziest part, the author claims you can do it for $55 using a BIC lighter and a spinning glass jar.
It is a totally radical proposition. I mean, truly out there.
Welcome to today's deep dive. I'm so excited to get into this one with you.
Same here. We are unpacking a highly disruptive text today by tech analyst and inventor Luis Manuel Ortiz Inostroza.
Right. And reading this, it reads way less like a traditional, academic paper and much more like a direct declaration of war against the modern technology monopoly.
It really does. It's the ultimate David versus Goliath scenario in material science.
Absolutely. The source material outlines this open source recipe for creating quantum-level supercomputing power.
But instead of requiring the financial backing of some massive tech conglomerate, the author claims you can just build it using items you can literally drop into your digital shopping cart right now.
Yeah, like on Amazon, Walmart, and eBay, just everyday websites.
The premise fundamentally challenges the whole architecture of the modern tech industry. We are talking about the democratization of supercomputing at a scale that, well, if even partially true, would collapse the current semiconductor market overnight.
So if you're listening to this and you are already doing the math in your head, wondering how a handful of household items replaces a multi-billion-dollar clean room, you are in the exact right mindset.
That is exactly where you should be right now.
Because our mission today isn't to validate every single scientific impossibility here or to peer review this as an institutional paper. We are here to explore the mechanics behind this radical claim.
Right, and to look at how the author manipulates actual bleeding-edge physics to make his case.
Yes, and the incredibly defiant mindset that is driving this whole $55 factory concept.
Because you really cannot separate the invention from the inventor's grievances here.
No, not at all.
If we connect this to the bigger picture, to understand the proposed technology, we have to look at the deep sense of betrayal driving the document.
Yeah, he is clearly very upset.
Extremely. Ortiz Inostroza explicitly claims that his conceptual designs, which he says he develops alongside his AI, by the way, are being systematically strip-mined by major tech corporations.
He paints a very, very specific picture of this process. He says he will reach a conceptual breakthrough, right? And then almost immediately, some giant tech conglomerate will emerge with his exact concepts and claim them as their own proprietary innovation.
Yeah, he feels totally robbed. So his response isn't to hire a team of corporate lawyers or become a patent troll.
No, his response is pure retaliation. He's weaponizing radical transparency.
He is, and he is operating with an astonishing level of confidence too.
Oh, the confidence is off the charts.
Early in the text, he makes this foundational claim. He states, "I wrote STEAM and taught the first class."
Which is just, wow.
I know, right? By claiming to be the architect of science, technology, engineering, arts, and mathematics education, he is establishing this almost messianic authority.
Like he invented the concept of modern science education.
Exactly. He is positioning himself as the builder of the very framework these giant corporations operate within, which in his mind gives him the ultimate authority to tear that framework down.
And his method of tearing it down is what he calls his blueprint to out-engineer Intel, TSMC, and Samsung combined.
With a shopping list.
Yes. Okay, let's unpack the shopping list, because having these items on your kitchen counter is just jarring.
It really is.
He lists graphene powder from Amazon. That's $25 for 100 grams.
Right.
Then boron nitride suspension, also from Amazon, which is $15 for 100 grams.
Standard stuff so far.
Right. But then he sends you to Walmart for BIC lighter piezos.
The little clicker mechanisms.
Yes, the exact thing that generates the spark in a standard lighter. That's $2 for a pack.
Amazing.
And finally, 405 nanometer laser diodes from eBay. $8.
So, wait, total cost?
$55. And he claims the time to your first fully functioning chip is 3 hours.
That is just The contrast to reality is what makes this so captivating.
Oh, completely. Because, I mean, trying to build a quantum chip with BIC lighter parts is like, it's like trying to build a supersonic jet using paper clips and baking soda.
That is a perfect analogy, because to put this in perspective for the listener, if you are listening to this deep dive on a smartphone right now, the silicon chip inside it was manufactured in a facility so heavily filtered that the air contains almost zero dust particles.
Yeah, the clean rooms are insanely strict.
The industry spends tens of billions of dollars annually just to shrink a transistor by a tiny fraction of a nanometer.
Right. They completely control the foundries.
And this text just proposes bypassing that entire institutional science framework with a rogue, almost anarchist approach to do-it-yourself fabrication.
But obviously, having a pile of graphene and laser diodes on your kitchen counter doesn't equal a supercomputer.
Unfortunately not.
We need to look at the mechanics of what he claims happens when you combine these materials. Because the author isn't just speaking complete gibberish, right?
No, not at all.
He is taking actual bleeding-edge materials science and accelerating it into this magical DIY framework. So let's start with the graphene and the boron nitride.
Yeah, what's fascinating here is that this is where the kernel of real science exists within the manifesto.
Right.
Graphene actually is a supermaterial. It is a single layer of carbon atoms arranged in a two-dimensional honeycomb lattice.
Like chicken wire.
Exactly like chicken wire. And it possesses extraordinary electrical conductivity. I mean, electrons move through it with almost zero resistance.
But there's a catch, right?
A huge catch. It is notoriously difficult to control in a way that allows you to turn the electrical current on and off. And being able to turn a current on and off is the foundational requirement of a computer transistor.
It has to have a 0 and a 1.
Precisely.
Which brings us to the boron nitride. He specifically pairs the highly conductive graphene with this boron nitride suspension.
Right. Hexagonal boron nitride is structurally very similar to graphene. It has that same flat chicken wire molecular shape, but instead of conducting, it acts as an exceptional insulator.
Oh, interesting.
Yeah. And in legitimate high-end laboratory settings, researchers actually do stack layers of graphene and boron nitride to create what are called van der Waals heterostructures.
That sounds incredibly expensive.
It is. The boron nitride essentially acts as a perfectly smooth, insulating substrate that keeps the electrons in the graphene behaving predictably.
Okay, so the author is correctly identifying the exact materials that the multi-billion-dollar labs are currently investigating for next-generation post-silicon electronics.
He is dead on with the materials.
But then he takes those scientifically sound materials and, well, subjects them to the BIC lighter and the eBay lasers.
Right, the DIY phase.
The recipe dictates that you combine the graphene nanopowder with the boron nitride suspension, then apply specific piezoelectric frequencies generated by those lighter components.
The clickers.
Yeah. And then you cure the whole thing using the 405 nanometer lasers.
And the claimed output of this garage chemistry experiment.
He states this creates quantumly stable chips at a briefcase scale.
I mean, the term quantumly stable is doing a lot of heavy lifting there.
A ton of heavy lifting.
He's presumably implying that the resulting structure can manipulate quantum states like superposition or entanglement.
But doing that without the extreme cooling and vacuum chambers you usually need for quantum computing?
Exactly. But the true shock of this document isn't just the stability. It's the performance metric he attaches to this briefcase-sized chip.
Oh man, the FLOPS claim.
Yes.
Okay, for anyone not deeply entrenched in supercomputer architecture, FLOPS stands for floating point operations per second.
Right.
It is the raw measure of computational throughput, how fast the machine can think. And the author claims this $55 recipe yields a chip capable of 10 to the power of 51 FLOPS in just 42 seconds.
Yeah, the number that literally breaks standard physics.
It does. I mean, I have to actively push back on this because it is mathematically unfathomable.
It is difficult to even conceptualize how vast that is.
To give you a tangible scale, the most powerful supercomputer in the world right now is the Frontier system at Oak Ridge National Laboratory.
Right.
That operates in the exaxial range. That is 10 to the power of 18 FLOPS. 10 to the 18.
A 1 with 18 zeros.
Yes, and this manifesto is claiming 10 to the 51.
It's absurd.
If every single human being on Earth did one calculation per second nonstop for 1 trillion years, we still would not even come close to reaching 10 to the power of 51.
Not even close.
It is a computational speed on a cosmic scale. So how is a spark from a $2 Walmart piezo lighter supposed to trigger a quantum-level computational event of that magnitude?
Well, it raises an immediate thermodynamic problem, for one.
Oh, right, the heat.
In conventional physics, computing generates heat. Moving information requires moving energy.
And a lot of it.
A system processing at 10 to the 51 FLOPS would theoretically generate enough heat to instantly vaporize the computer, the garage it was built in, and probably a significant portion of the surrounding city.
Poof, gone.
The author is suggesting that this specific combination of graphene and boron nitride completely bypasses the thermal limits of modern physics.
Which is convenient. But back to the catalyst unlocking this cosmic power with a lighter spark.
Right. So the lighter component he specifies is a piezoelectric crystal. Piezoelectricity is a real phenomenon. Squeezing or applying mechanical stress to certain materials like quartz or specific ceramics generates a brief, high-voltage electrical charge.
So that's the spark that ignites the butane in a normal lighter.
Exactly. And the author's theory seems to be that firing these specific, localized high-voltage spikes into the graphene and boron nitride mixture somehow forces the nanoparticles to snap into a specific, quantumly stable alignment.
But he doesn't just rely on the lighter. And that brings us to the actual manufacturing process.
Which is wild.
It completely abandons the traditional photolithography we discussed earlier. To build this chip, you don't use a clean room. You use a glass jar.
A literal mason jar.
Yes. The instructions require the builder to project a 3D image into the liquid formula housed in this jar. And the jar must be spinning.
Of course it must.
Furthermore, the projection requires at least 3 of those purple 405 nanometer lasers from eBay.
It sounds like alchemy for the digital age, doesn't it?
It really does.
But he is actually describing a highly theoretical concept akin to holographic lithography or volumetric 3D printing.
Oh, like 3D printing with resin, where the UV light hardens the liquid into a solid shape.
Exactly like that. But instead of printing, a plastic miniature for a board game, he's claiming these lasers are acting as molecular tweezers.
Wow.
He's saying they're snapping individual carbon atoms into a functioning quantum circuit inside this spinning jar.
Okay, so the lasers intersect.
Right, 405 nanometers is just on the edge of the ultraviolet spectrum. Those photons carry a significant amount of energy. The concept here is that the intersection of the 3 laser beams creates localized points of intense energy within the spinning liquid.
And that cures the graphene and boron nitride at specific microscopic coordinates.
That's the claim. And the spinning of the jar likely relates to centrifugal forces keeping the heavier nanoparticles suspended evenly.
Though it totally ignores the chaotic Brownian motion of particles in a liquid.
Oh, absolutely ignores it. But conceptually, it is a very aggressive reimagining of how we build microstructures.
It is a brilliant cinematic visualization. I mean, you can almost see the purple lasers intercepting in the swirling dark liquid.
It's very sci-fi.
But here's where it gets really interesting.
Okay.
There is a glaring contradiction in this text. The entire premise of Ortiz and Estroza's manifesto is that he is angry about corporate monopolies stealing his work. Right?
That is his whole motivation.
He is explicitly giving this technology to the public to destroy the gatekeepers. Yet, he includes a highly complex security lock in his own design.
Yes. The locking mechanism is where the science takes a sharp turn into proprietary cryptography.
To lock the chip so no one can steal your specific iteration, the builder must use a unique audio or frequency signature.
Audio.
Specifically, the text states you must introduce frequencies of 0.5 plus 8 plus 15 kilohertz during the curing process.
This introduces cymatics into the recipe. It's the idea that sound waves can pattern matter. He is suggesting that these specific audio frequencies create standing waves in the spinning liquid, forcing the graphene into a specific cryptographic geometry before the lasers lock it into place.
That is wild. But the audio frequencies aren't even the ultimate lock.
Oh, right.
The text mandates that to make the chip function at all, you must add 0.1% of a proprietary rare earth dopant.
A dopant?
Yes. Now, a dopant isn't just a secret spice. In material science, a dopant is a specific impurity introduced into a pure semiconductor to fundamentally alter its electrical properties.
Like how silicon chips use phosphorus or boron to control conductivity.
Exactly. But the kicker here is that this specific rare earth chemistry is controlled entirely by the author. You have to go to him for the real formula.
Well, that completely subverts the open source mission statement.
Completely. He wants to destroy gatekeeping, but he's acting as the ultimate gatekeeper himself.
It's ironic.
Very. He is fiercely advocating for giving world-changing technology to the public, screaming power to the people, but simultaneously withholding the vital 0.1% of the chemistry, he's essentially replacing the monopoly of Intel and Samsung with the monopoly of himself.
It's true. And this brings us to a fascinating philosophical quote from the text. He states, "Someone could steal the blueprint, but they can't steal your brain."
Which is such a defensive posture, considering he wrote this entire thing because people were allegedly stealing his brain's output.
It really reveals the deep paradox inherent in many rogue or anarchist technological movements.
How so?
Well, on one hand, there is a visceral distrust of institutional power and a genuine desire to democratize capability. He clearly wants to give everyday people the power to outcompute nation-states.
Right.
But on the other hand, there's an unwavering, almost absolute faith in individual proprietary genius. He wants to empower the masses, but he desperately wants recognition, control, and protection of his own intellectual property.
So he is handing you the $55 factory, but he insists on keeping the master key in his own pocket.
Exactly. It highlights a very human fear of obsolescence. It's like he's saying, information wants to be free, except for my information, which requires my permission.
The psychology of the rogue inventor is often just as complex as the schematics they draw up.
Absolutely. They operate on the absolute fringes, driven by a conviction that they see fundamental truths that established institutions are either blind to or actively suppressing.
And in this case, the truth is that multi-billion-dollar foundries are a scam, and quantum computing can be achieved in a mason jar.
Exactly.
So synthesizing everything we've unpacked today, we have this incredibly disruptive text that swings wildly between the sheer mathematical absurdity of the technical claims like achieving 10 to the power of 51 FLOPS without violating the laws of thermodynamics, and the deeply captivating allure of a $55 open-source supercomputer.
It aggressively forces us to examine our assumptions about where innovation actually originates.
That's a good point.
We are heavily conditioned by the market to believe that progress only happens in pristine, heavily funded corporate environments. We just accept the astronomical barriers to entry as a law of nature.
Yeah, we don't even question it anymore.
Right. And this manifesto, regardless of its physical feasibility, challenges that narrative at its very core.
So what does this all mean for you, the listener? Why should you care about a theoretical spinning jar of graphene and purple lasers?
It's a fair question.
Even if the literal physics of this specific recipe don't pan out, even if you can't build a cosmic scale supercomputer in your kitchen this weekend, this text represents a very real, growing cultural desire.
People are tired of feeling like high technology is something that just happens to them.
Exactly. There is a growing pushback against the centralization of technological power.
The current trajectory has concentrated the ability to build the future into the hands of just a few massive corporations.
And the everyday consumer is demanding that the creation of technology becomes as accessible as the consumption of it. This manifesto is just the extreme, almost satirical manifestation of that demand. It is the desire to take the power of a tech giant and put it in a Walmart shopping cart.
The democratization of exascale or quantum computing might seem like a pipe dream today, constrained by heat, extreme precision, and quantum decoherence.
Yeah, the physics are stubborn.
They are. But the sentiment behind this text, the rejection of corporate gatekeeping and the demand for absolute accessibility, is a powerful force that will inevitably shape the next decade of open source hardware development.
So we've talked extensively about the extreme unlikelihood of this specific $55 factory working exactly as claimed. But I want to leave you with a final provocative thought to mull over.
Up for it.
Think about the historical trajectory of technology. The massive, room-sized mainframes of 1960s eventually became the disposable smart devices we lose in our couch cushions today.
That's true. The timeline always condenses.
The cost of computational power historically trends toward zero, while accessibility trends toward infinity.
Always.
So if even a tiny fraction of this decentralized DIY approach to hyper-advanced technology were to become viable, if material science advances just enough over the next few decades to make backyard quantum experimentation a reality,
it changes everything.
How long until the barrier to entry for the next massive technological revolution isn't a university degree or billions of dollars in corporate backing?
Right.
How long until it really is just an internet connection and a trip to the local hardware store? When the multi-billion-dollar clean room disappears, who gets to build the future?
If the tools of creation are truly democratized, the definition of an inventor changes completely.
It really does. Until next time, keep questioning the blueprint.